Far by Haley Rice, Priscilla Garcia, Bianca Gomez, and Nick Davis.
Forensic investigation of arson. Modus operandi is an offender's pattern of operation. Accidental causes usually leave more chemical traces. The ultimate determination must be made by an investigator with practical experiences in fire investigation.
The chemistry of fire. Oxidation is the combination of oxygen with other substances to produce new substances. Oxidation is not always related to fire. Iron oxide, also known as rust, is a form of oxidation.
Energy. Energy is the ability or potential of a system or material to do work. Energy can be in many forms, including heat, electrical, mechanical, nuclear, light, and chemical. Examples: heat can be used to boil water to produce steam to power a turbine, turning chemical energy to mechanical energy.
Combustion. Combustion is the combination of oxygen with another substance, accompanied by production of noticeable heat and light. Endothermic reaction is a chemical transformation in which heat energy is liberated. Heat of combustion is the heat liberated during combustion. Ignition temperature is the minimum temperature at which a fuel spontaneously ignites.
Speed of reaction. Physical state of fuel. The gas from fuel ignites to produce a flame. Fuel temperature is liquid fuel. The temperature must be high enough to vaporize the fuel. The vapor burns when mixes with oxygen and combusts as a flame. Flash point. The minimum temperature at which a liquid fuel produces enough vapor to burn. Pyrolysis. The chemical breakdown of solid material.
The fuel-air mix. A mixture of gaseous fuel and air burns only if its composition lies within certain limits. If it's too low or rich, combustion does not occur. Glowing combustion. Combustion on the surface of a solid fuel in the absence of heat high enough to pyrolyze the fuel. An example is a burning cigarette or hot charcoals. Spontaneous combustion. A fire caused by natural heat producing process in the presence of sufficient air and fuel.
Examples of spontaneous combustion: not properly vented hay. Eventually, the heat rises. The ignition temperature of hay is reached, spontaneously setting off a fire. 3 requirements must be satisfied. 1. A fuel must be present. 2. Number 2. Rudely interrupted. Oxygen must be available in sufficient quantity to combine with fuel. 3. Heat must be applied to initiate the combustion, and enough heat must be present to sustain the reaction.
Heat transfer. Conduction. The movement of heat through a solid object. In reconstructing a fire scene, it is important to remember that heat may be transferred through metals such as beams, nails, fasteners, and bolts, creating a new fire location. Radiation. The transfer of heat from a heated surface to a cooler surface. In a fire scene, the radiation moves in a straight line from one surface to another.
For example, surfaces exposed to the fire are exposed to radiated heat and burst into flames when they reach the ignition temperature. Conduction is the transfer of heat by movements of molecules in liquid or gas. Compared to boiling water in a pot, in a structural fire, the gaseous products of combustion expand, and convection moves the hot gases to the upper portions of the structure. Flashover occurs when all the combustible fuels are simultaneously ignited, engulfing the entire structure in flame.
Searching the fire scene. Investigators should examine for signs of arson as soon as the fire is extinguished. The presence of containers holding an accelerant around suspicion of arson. Examples of accelerants: gasoline and kerosene. Telltale signs of arson is an irregular shape pattern on the floor or ground, resulting from pouring an accelerant onto the surface.
Timelines of investigation. Accelerant residues that remain after a fire may evaporate within a few days or hours. Once this occurs, a meaningful investigation of the crime scene is impossible.
Locating the fire's origin. Streamers, evidence of separate and unconnected fires that spread from one area to another. probable origin is most likely closest to the lowest point that shows the most intense characteristics of burning. The point of origin should be protected to permit careful investigation. Examination must be made for possible accidental causes as well as for evidence of arson.
Searching for accelerants. The search for traces of flammable liquid residues may be aided by the use of a portable vapor detector.
Collection and preservation of arson evidence. 2 or 3 quarts of ash and soot debris must be collected at the point of origin of a fire when arson is suspected. The collection should include all porous materials and all other substances thought likely to contain flammable residues. These include such things as wood flooring, upholstery, rugs, and rags.
Packaging and preservation of evidence. Specimens should be packaged immediately in airtight containers so possible residues are not lost through evaporation. Clean paint cans with friction lids are good containers because they're airtight, not breakable, and available in a variety of sizes. Wide-mouthed glass jars are useful because they provide airtight lids as well. Cans and jars should be filled 1/2 or 2/3 filled full. Large, bulky samples should be cut to size at the scene as needed so they fit into available containers. Hydrocarbon, any compound consisting of only carbon and hydrogen.
Gas chromatography and mass spectrometry.
Discernible patterns are not obtainable by gas chromatography. Gas chromatography combines with mass spectrometry has proven valuable for the detection of accelerant residues, and that's far.